morning, students. Let us start the today's session. It is flow of charges. Actually, what is flow of charges? It is nothing but from one point to the other point, the flow of electrons is called as flow of charges. So when it attains a stability, up to that moment the charges or the electrons will be flowing from one end to the other end. For that, when you connect two spheres or a metallic spheres with a wire, what will happen? Excess electrons from the negatively charged sphere will start flowing towards the positively charged sphere. Imagine that in the one sphere is full of negative charge and the other sphere is full of positive charge. So from the metallic sphere, one having more negative charges will start flowing towards the positive charge to the next sphere. This flow will continue up to the moment both the electrons on both the spheres get stable. Both will become equal or stable. These positive charge spheres is said to be at higher potential. Okay, the positive charge sphere is be having high potential and the negative charge will be having the low potential. Okay, so this is how the flow of charges is the flowing of electrons, and electrons flow from a lower potential to a higher potential. So always the electrons will be flowing from a lower potential to a higher potential. This is known as electric current or flow of electrons. Okay, understood? Then the difference between this potential is known as potential difference, commonly known as voltage. You know voltage, sometimes the voltage will be high, sometimes the voltage will be low. That means the flow of electrons is called as electric charges, and when in the negatively charged it will be having lower potential, in the positive charge it will be having high potential. So the difference between this potential is known as the voltage. Okay. Now, before the discovery of electrons, it was considered that electric current is due to the flow of positive charges alone. So, before the electrons, it was found that always it is because of the positive charges flowing. Conventional current flows from higher potential to a lower potential. So, conventional current always it flows from a higher to a lower. But electrons, it is not like that. It is from a lower potential to a higher potential. So, we'll underline that conventional current is always from a higher to a lower potential, but electrons is always from the lower to higher. It is just vice versa, or just the opposite, or just the ulta. Now, next comes the topic is electroscope. An electroscope is a scientific instrument used to detect the presence of electric charge in a body. To detect the electric charge in a body is the device used is called as the electroscope. It is the first electrical instrument, and it was found by a physician, William Gilbert, invented the first electroscope. An electroscope is made out of conducting materials, generally metal. It is always made by the conducting material. Conducting material which passes the current are called as the conductors, or the good conductors of electricity. It works on the principle that like charges repel and unlike charges repel each other, and the unlike charges will attract. That means positive and negative always it will attract, and the like charge, two positive, two negative, it will repel. In a simple electroscope, two metal sheets are hung in contact with each other. So how this electroscope is made? So when I am reading, you can understand in your mind. In a simple electroscope, two metal sheets will be there hung in contact. It will be hanging from one contact with each other. Two metal sheets, they are connected to a metal rod that extends upwards and ends in a knob at the end. So it will be having two metal sheets. It will be hung from one end, and it will be having a knob from where it is attached, and extends outwards, and it will be having a knob at the end of that. See in the diagram they have shown it. Near the knob of the electroscope, the free electrons in the electroscope start to move towards the knob. So free electrons will be moving towards the knob. This means that the bottom has a positive charge. So always it will be flowing from where? From low to high. So from the lower to high positive charge, it will be from the negative to positive. The leaves will spread out apart again now. So the leaves will be spread out. See, like two leaf like structures will be, it will move aside in both the directions. This is a structure of a simple electroscope. Now they are giving the example of a gold leaf electroscope. The gold leaf electroscope was developed in 1787 by a British scientist named Abraham Bennett. Gold and silver are used in ultrascope because they are the best conductors of electric current. Always the gold and silver are used because it is the best conductors of electric current. And ultrascope. It is made up of a glass jar. If it is made up of glass jar only, we can see or visualize a leaf like electrodes inside. The vertical brass rod is inserted into the jar through a cork. So, see the diagram when I am reading. So, what is inserted inside? When the a vertical brass rod is inserted into the jar through a cork. Through the cork means on the top the closing lid is called as a cork. The top of the brass rod has a horizontal brass rod or a brass disc. See that brass disc coming down. Two gold leaves are suspended from the brass rod inside the jar. So from the knob when it is coming down to at the end of the brass brass rod, there is two leaf like gold leaf. Working electroscope. Working of electroscope? How this works? When the brass disc of the electroscope is touched by a charged object, any charged object, when we bring near to that knob on the top, that bowl-like structure on the top, when we bring it together, electric charge gets transferred from the gold leaf through the rod. Through the rod from that object, it will transfer all the electric charges down towards the leaf. This results in gold leaves moving away from each other. They both will be moving away. Why? It is moving. This happens because both the leaves have similar charges. When it is moving away means what? It is having a like charges. So like charges will repel. So when both the leaves have to come together, that means it should be one positive and one negative charge. Then only it will attract each other. Okay. Charging. Transfer of charge from one object to another is called as charging. So you know nowadays what is charging, isn't it? When we put the mobile phones in the charge. So transfer of charge from an object to another is called as charging. In case of gold leaves, charge is transferred through the brass rods. From the brass rod, from the knob through the brass rod, it will reach to the two leaves. Electrical discharge. The gold leaves resume their normal position after some time. They will come to the normal position because the charges, it has become stable. It will come to the normal position. This happens because the loss their charge. This process is called as electrical discharge. The gold leaves would also be discharged when someone touches the brass rod with bare hands. If you touch with your bare hands, then also the charges will be discharged. In that case, the charge is transferred to the earth through a human body. Human is always a good conductor of electricity. So, a charged body or our hands or anything, through the earth only the charges are getting reached to the earth. Now, next one is lightning and thunder. So, recently only the rain was over, so you know what is lightning and thunder. Rub your foot with a carpet floor and touch the door knob. What do you feel? Do you feel the shock in your hand? Why does this happen? Because of the electric charges getting charged from a body, the charges are flowing, so because of that. Getting a shock from a door knob or rubbing your foot on the carpet floor results from a discharge. Discharge occurs when electrons in the hand are quickly pulled to the positively charged door knob. This movement of electrons, which is felt as a shock, causes the body to lose negative charge. Electric discharge takes place as a medium, mostly gases. Lightning is another example of discharge that takes place in clouds. How the lightning occurs you have studied in your primary classes. So this is a give reason question and this is the answer for that up to this one. Then lightning is produced by discharge of the electricity from cloud to cloud or from cloud to the ground. During thunderstorm, air is moving upward rapidly. The air which moves rapidly means very fast, carries the small ice crystals upward. At the same time, small water drops move downwards. When they collide, when these ice particles which is carried away, ice crystals carried away up and when the water drops comes down, they will collide and what will happen? The thunder sounds will come. The ice crystals become positively charged and move upwards and water drops become negatively charged and move downward. So the upper part of the cloud is positively charged and the lower part of the cloud is negatively charged. So when these ice crystals are moving out, the water drops come down. So they will collide each other and the water drops become negatively charged and move downwards, and which is positively charged, it will move to the upper positive charge, and the lower part will move the negatively charged charge will be there. When they come into contact, electrons in the water drops are attracted by the positive charges in the ice crystals. Thus, electricity is generated and the lightning is seen. Sometimes, the lower part of the cloud, which is negatively charged, comes in contact with the positively charged charges accumulated near the mountains, trees, and even people on the earth. This discharge produces a lot of heat and sparks that results in what we say as lightning. Huge quantities of electricity are discharged in lightning flashes, and temperatures of 30,000 degrees Celsius for more than can be reached. The extreme heating causes the air to expand explosively, and then they contract. This expansion and contraction create a shock wave that turns into a booming sound wave known as thunder. So what is thunder? It is the heat. The heat of the air causes the expansion of the upper and the lower. Because of the flashes of light, the air gets expanded explosively and they contract. The expansion and contraction create a shock wave that turns the booming sound of the wave known as the thunder. So lightning extreme heat will vaporize and water inside a tree, creating steam that may burn out the tree. Then sometimes lightning may be seen before the thunder is heard. This is because the distance between the clouds and the surface is very, this is also a give reason question. This is because distance between the clouds and the surface is very long, and the speed of light is more than the speed of the sound. So this is the lightning and thunder, and next class we'll go for what is earthing. Okay, so thank you students.